For t distribution, also called student's distribution, because the sample size is small and the graph may not be the same as the normal standard distribution. As you can see, this line, solid line curve, the bell-shaped curve, is the normal standard deviation with the population mean equal to 0 and standard deviation equal to 1. And the dotted line is degrees of freedom is equal to 5, which means the sample size is 6, because degrees of freedom is sample size minus 1. So when the sample size is 6, we draw the distribution. As you can see, it's more spread out and it's pushed down a little bit. But when the degrees of freedom are 2, which means the sample size is 3, and it's down further. And so because of this, because the graph for t distribution may not be exactly the same as standard normal distribution, and that's why we have a different table. So when we look at the table, as we can see that we can see here that this is t distribution graph, and the table is set up a little different because the graph changes, the bell shape changes, the curve changes when the degrees of freedom change. So we have to have a column for degrees of freedom. And when we did normal standard deviation, because we always consider the sample size large, we don't have to worry about the sample size. But for small sample size, when the sample size changes, the graph does change. So that's why we have to have a column for degrees of freedom. And so the setup is completely different from standard normal distribution graph table. And the other difference is for normal standard distribution, usually we have 2 pages. One side is for all the negative values, one page is for all positive values. But to make things easier, we're only going to create one side, and we're not going to create the left-hand side, because the left-hand side is symmetric to the right-hand side. If you know the right-hand side, then you have left-hand side. And also the big difference here, because we want to use all the positive values. We don't, in the table, we don't really want to put a lot of negative sign, all the negative signs. When the area, the left side area, all the corresponding z values are negative. And notice this time, the value we have in the table are going to be what we call t value, but similar to the z value we had before. So if we can look at the standard normal distribution table, first of all, the area is the left side area, but we have the right side area to get all the positive t values. Secondly, we have a column for all the z values, first row, first column. But all the numbers in the middle, these are probabilities, or the area under the curve. But for t distribution table, it's opposite. The first row is going to be our probability. And so as you can see, this table is very limited because there's so many probability numbers, but we only given 0.25%, 10%, 5%, and 2.5%, and 1%, and so on. So we are not given as many values as we have for standard normal distribution, because we have all the different probabilities. And the other thing is, so all the numbers in the table will correspond to this t value, or what we previously called z value, first row, first column. So it's kind of switched. Z value we had first row, first column. The numbers in the middle of the table, these are probabilities. But for t distribution, the first row is the probability. The numbers in the table, these are the t value, which is similar to the z value we had before. So when we use the table, we also have to use it differently. Let's look at example. Find B so that P, the probability, P means probability, for t greater than B is equal to 0.10, which is 10%, when degrees of freedom are 17. So we look at the table. That we can always sketch the graph to help us understand the problem. It's also bell-shaped, but the bell shape is a little different from as we looked before. It's more spread out. And next we have t greater than b. So this, whatever this t value is greater than b value, that means greater than, it's gonna, let's put this as our b value, greater than t. T is greater than b, so t is gonna be all these numbers on the right side of b. And the p probability means the area under the curve is equal to, so the area under the curve is equal to 0.10. Let me mark it here. So this area is going to be 0.10, the shaded area. We're solving for b. Previously, when we did normal standard deviation, we called it solving for a z value, but this is sort of like a t value we're looking for. So let's look at the table. First of all, the area is the right side area, which matches our graph right here, right side area. And this area is 0.10. So remember the area's probability, and which is given in the first row. We call it alpha, first row. And so we found 0.10 right here. And degrees of freedom are 17. So we go down the first column, degrees of freedom, 17. And we look at the intersection, which gives us 1.333. So that means this b value right here is equal to 1.333. So b equals 1.33. Now, secondly, let's look at another question. What if it's t less than? So I'm going to change the question from greater than b to less than b. How do we do it? Let's draw another graph, bell-shaped graph. And less than b, so it's going to be numbers on the left side of b. So that's going to be these values. And the reason I know I'm going to have to move to the left end, because the area is only 0.10. It's only 10% of the whole area. So that's why I wouldn't put a b right here, because exactly in the middle we're going to have a 0.5, because 0.1 is less than 0.5, unless we are given an area such as maybe 0.9. That's going to be bigger than 5, so that b will be on the right side. Otherwise, in this case, because b is 0.10, that's only 10% of the whole area. So that's why I know I put b to the left side of 0. And that's going to be a negative. And so this area is going to be 0.10. And we're solving for b. And notice that we cannot really use the table directly, because the table only gives us the right side area. But we can notice that if you draw a left side area, it's going to be symmetric. So what we can do is we can draw a symmetric, let me use a different color. So we can move this, take like a symmetry. Gonna get this right side area. So this area is gonna be the same as that area, 0.10. And the number I found would be opposite of the b value. So whatever this value is, I take the opposite, I'm going to get the b value we're looking for. So this b value is the one we're looking for. But in order to use the table, we have to move this left side area to the right side area because of the symmetry. And if I found this value right here, it's just this b value is going to be opposite of that. So similarly, we did it as we did it before. That's going to be the right side area, which we can use the table. So it's going to be exactly the same as this. So this value here is 0.133, and that means b is going to be negative 1.333. So in this case, b is going to be equal to negative 1.333. Now next we're going to do a case with what if we have, let's say, in between. So suppose we have negative b to t less than b, is equal to 0.90. So let's draw a graph to help us. B is on the right side of 0, and negative b is on the left side of 0. And it says that t is between negative b and b, which means t is going to be these values from negative b to b. And the area under the curve that corresponds to p here, probability, is equal to 0.90. So now we cannot use the table directly because this area is the middle area. So in order to use the table, we have to have the right side area. So let's find this right side area here. And notice the total area on the curve is 1. So we're going to take 1 minus 0.90, and these two ends, they are symmetric. So which means this area right here is the same as the right side area. And so we divide by 2. 1 minus 0.90, we get the total area of these two shaded area in red. And divide by 2, I'm going to get a 1 of them. So we get a 0.10 divided by 2, which is 0.05. This is 0.05. Now I'm going to go to the table to find, remember this is the area, which is also the probability. So we're going to look at the table to look for 0.05 right here with degrees of freedom 17. So we have 1.740. So that tells us this is 1.740. And the other side, negative b, of course, is negative 1.740. So in this case, we found the b value. It's 1.740.